The very last part of 6.6 is to do the composition of functions, but to do it specifically with actual expressions, variables, and not just with numbers. So I cut and paste all three of these questions from Delta Math because I feel like it's really helpful when you see exactly the way the question is going to be asked and what they're asking for. So this is asking you, it's going to give you two functions, f and g, and it's going to ask you to do a composition of those functions. So here's how you want to work, and I'm going to color code a lot because I think that helps. When you do this, you're going to take the inner function. We always work inside out with compositions, and you're going to put that entire inside function into the outer function. So what this is going to look like is you're going to take the entire g function, which is all of this right here, and you're going to put it, you're going to do a substitution into the f function where you see the variable x. So you're going to have, I'm going to still try to color code this. You're going to still have the 4, but then instead of an x, you're going to plug in x squared plus 4x plus 2. You're going to put that g function in where you see the x, and then you're still going to have a plus 5. So notice what I did. I took that entire g function and I put it right where the x was in the f function. Now, to answer your question, you are going to have to do some simplifying when it's all done. So that may mean distributing, it may mean combining like terms, it might mean both. So in this case, you're going to distribute the 4. So 4 times x squared, 4 times 16, or 4 times 4x, and then 4 times 2. So again, distributing, distributing, distributing. And then I'm going to combine like terms. So my final answer, I don't know why I put a squared here, I'm sorry, is 4x squared plus 16x plus 13. That is in standard form, meaning highest exponent to lowest exponent, or in this case, no exponent at the end. So that's how we do a composition of functions that are not numeric. We still work inside out. So I'm going to do this one the same way. I really like color coding. I think it helps. So we're going to put the g function, which is all of this, and it's going to go into the f function where you see that x. So you're going to have -4, but instead of x, you're going to replace that with the entire g function, which is x squared plus x plus 9. And then you still have the -10. So all I did is I replaced this x with the entire g function. Then, as I mentioned, you're going to have to distribute. So you get -4x squared, -4x, and -36. And then you still have the -10 at the end. You're going to combine like terms, the constants at the end. So you have -4x squared minus 4x minus 46. And this is your final answer in standard form that you're going to type into Delta Math. Last one is actually doing the opposite. So I wanted you to see one of these as well. So now we're going to take this f function and we're going to put it into g. So my f function is the inner function. It's going to go into g. It's actually going to go two places. It's going to go both places there's x's in the g function. So we're going to have x squared. So that's going to be the entire 2x plus 1 squared plus 5 times x is going to be replaced with 2x plus 1 plus 10. So notice that both places there was an x in that g function we replaced with 2x plus 1. And I like to do it in a separate color because I just think it makes sense. Now to multiply this out, I'm actually going to come off to the side and I'm going to write 2x plus 1 times another 2x plus 1. Because that's what I have to do to get this, is I have to square it out. So I'm going to have to FOIL. So 2x times 2x, that's your first, is 4x squared. My outer 2x times 1 is going to be 2x. My inner is also going to be 2x. And then my last is going to be 1. And then I'm going to add my like terms. So when I square it out, I'm going to come back over here. I get 4x squared plus 4x plus 1. That's basically doing some work off to the side. Then I'm going to have to distribute the 5 here. So 5 times 2x is 10x, and 5 times 1 is 5. And then I have the plus 10 at the end. So I have more terms with this. This one is definitely a little harder. You're going to see more of the top type. I think I'm having you do 3 of those and only 2 of the harder type just because I know they're more time consuming. So you are going to have to combine like terms to finish this. So I'm going to underline them just to have them show off to you. So my final answer is 4x squared. I have a 4x and a 10x, which is 14x. And then I have a 1, a 5, and a 10. So 1 plus 5 plus 10 is 16. And that is my final answer. So that is how I compose functions inside of functions. It does help if you have like a second color or you have something that you can circle to show that that entire function is taking the place. When you put an entire function into another function, keep it in parentheses. That will remind you that there's going to be distributing or foiling or combining that has to happen. And that's the end of 6.6, all of the composition stuff that you'll be asked to do.